Hello, and welcome to my talk about how Matter produces an outside-in view on companies' sustainability performance. This talk, I will talk about how Matter utilizes natural language processing to create an inside-in view on companies in relation to how their sustainability performance is on the SDGs, from data source to client-facing API. Um, I'm a lead AI scientist at Matter. I'm a machine learning engineer, and I'm working from idea to deployment. I have a vast knowledge within NLP and deployment of large-scale data pipelines, machine learning models, and AI governance. I lead a team focusing on utilizing different machine learning techniques to support Matter within sustainable finance and keeping a vertical transparency to clients. In this talk, I will just briefly go over what Matter provides and how we saw the possibility of using NLP, creating a annotation methodology, annotating data, building a pipeline, and in the end, of course, serving the data as well. So Matter provides sustainability insights on financial assets in a 360-degree view. And we do that by connecting financial industry directly to the insights from leading sustainability experts. Um, so we go beyond black box ratings, as so much is lost when the complexity of sustainability is reduced to just a number. So we strive to provide complex but not complicated insights, empowering clients to react without the need of understanding super complex analytics. And we enable clients to react faster on how companies operate. And we have developed SGD Signals, a proxy for company sustainability doings. It all started back in early 2019, where Matter was in the process of building its core systems to analyze financial assets. And back then, we used a variety of data. Though over 2 years ago, data on sustainability was lacking and usually very sparse and had very little coverage as well. So it was a problem creating a full view of a portfolio if 30% of the assets were missing sustainability data. A lot of the data were also inside-out measures, meaning that the companies were providing its own data, such as CO2 emissions, waste generation, water usage, and so on. This is usually fine, but of course raises the questions about the trustworthiness of the data. So we needed a way to create an outside-in view in terms of what the rest of the world is saying about a company in a good or bad way, of course, in the sustainability context. And the context is the important thing here. So, of course, the first thing that we got to was data annotation. I'm starting this project of seeing how a company is set to how they're perceived in the media, and the most important step of any machine learning project, I think, is the data annotation, and there should be a lot of governance around it, and should have a bulletproof methodology to support what you're doing. This way, you can easily convey your machine learning models and what they're learning from as well, and how trustworthy the data is. Over 2 years ago, there was no really precedent within sustainability finance in terms of the task that we wanted to solve. Of course, sentiment models have existed for many years, just not in the way that we wanted to use sentiment. The frameworks at the time was also very fluffy and blurred. It was making a hard time to develop a annotation methodology directly from a framework. So this made us realize that we needed an iteratively way to work with our annotation strategy and how to continuously improve it. In 19, sustainable finance had a lot of hype and continuously have had that ever since. But as any field with a growth that is so extreme, it also lacked what it actually means from a legal perspective, but also in terms of political frameworks of what sustainability actually means for a company, and when is a company sustainable and when is it not. So at the time, mostly work with the Sustainable Development Goals from the UN, and so did we. It is a comprehensive framework that is very broad, um, but it's also uh, a little bit vague. But at least all countries in the world agreed to it and agreed that this is the things that we need to work with towards 2030. And some of the areas in the SDGs is not completely covered due to differences between countries, but we took this anyway as a basis to build our annotation framework on top of it. When we work with annotation, we usually do it in 6 different steps. And we run these continuously to get a solid methodology. And it's especially powerful in the first stages. The first stage is what is called model. And this is not actually anything to do with the machine learning model, but more in creating a description, theoretically, about the domain and what kind of attributes can we derive from empirical observations of the data or the data domain. And of course, this usually starts with doing some exploratory work, identifying potential descriptors that we want to annotate. Here, it's also very nice to use domain experts to identify some patterns, and this will inherently lead to emerging annotation classes and tags that you can use in your annotation strategy. Next step is actually to annotate the data using the things that you learned from the model step. Then you train your algorithm, see how it performs, test it, evaluate it on some kind of metric. That could be accuracy, recall, precision, if one score, and any other metric that could evaluate the performance of your system. And the last step is then to revise, and that is taking the model and the annotation specifications and see if the things that we have trained and evaluated actually performs the way we saw it should do, and if it solves our problem. Usually in the start of a project, we go back and forth between model and annotate a couple of times to develop our descriptors and attributes in the best way. After that, when we have developed a solid annotation strategy, we of course choose some annotators, and we employ some different kinds of metrics to help us continuously gauge whether the annotators is performing as they should. We use a series of golden questions, or honeypots as some call it, and it's a predefined golden set of data that are known to be 100% correct, and also their annotated classes. And this is usually created by the stakeholders or the ones that are leading the project, and they will be injected into the annotation data set, and then continuously evaluate what the annotators are annotating on those questions. And by that, we can gauge if the annotators are aligned and answering correctly to the questions that we know should be correct. Then we also use some metrics that are does not use a base data set, and that could be either Fleiss kappa or Cohen's kappa, depending on how many annotators you have, and we can use that to track the coherency of the annotation group. And we do that by simply overlapping some of the data points between attackers. Another way could be unanimous voting. It can also be a sufficient way to validate in an automatic way how the annotators are performing, but it also is a little bit more expensive strategy. as it requires a lot more tags. Unanimous voting is basically taking the majority vote on each data point and using that as the class label. But this requires at least 5 different annotators to perform good, basically. When working with language, there is a lot of different barriers to the language that is important as well, and some of those can be syntactic, semantic, and intent-based errors that are very common. Syntactic errors is basically when there happens an ambiguity in the data, that a sentence structure can mean different things depending on who you are and how you read it. A semantic error can be that a piece of text can have multiple semantics, so meaning more meanings, and this kind of collisions can introduce semantic instability in a machine learning model. It is therefore important to have a coherent semantic view from all the annotators. There's also intent-based errors, which is kind of the relationship between the annotation framework and the annotators. And the more strict your annotation framework is, the more we reduce the risk of having intent-based errors. And basically, the intent-based errors is when there is so much freedom in the annotation framework that it does not work anymore, because the annotators have the freedom to choose, because maybe the classes are a little bit too vaguely described, so they can choose more freely between them, and that gives inconsistency in the data. For our annotation purposes, we have created an in-house annotation web application. As you can see here on the image, it's present sentences to our annotators, and they have to annotate. In this case, they annotate positive, negative, and neutral sentiment. They also have the options of putting it into a doubt category or skipping it altogether. When we hired our annotators, we went for university students, recent graduates that had a good knowledge within sustainability and sustainable finance. We educated them in our methodology and how we basically see the SDGs and sustainable finance. We then conducted a screening test on a small set of questions or sentences that they had to answer correctly to proceed. And this was kind of a quality assessment. We then let them use the annotator app that is hooked directly up to our databases, so we get a good domain representation. We then continuously had checkups with our data and our annotators, see what they answered wrong, and also the data points that they labeled doubt, and then discussed what the annotation methodology needed to be more certain in those situations. And all this helps us make a unbiased data set that is of a very high quality, and we know exactly why each tag was made as well. After the whole annotation, which can take a lot of time depending on the data size that you need, we begin building our pipeline. Our pipeline consists of 5 different steps, and the first step is, of course, extracting data from our providers, and we do that on a article level that we daily search through a range of keywords, and we search through around 10 million articles from 150,000 different sources, and we search only for sustainability related news that are relevant for us. And on average, this yields us around 80,000 articles every day. So it makes a lot of sense for us to filter on the content of the news. So we don't analyze any data that is not necessary for us. The next step is deconstruction of the articles. We deconstruct every article down to sentences, and that makes it a lot easier for us to work with. We can then later reconstruct the articles if we want to. But then that means that we have deconstructed it down to smaller tasks that our systems need to deal with. We have a transformer-based model to extract the sentence embeddings for each sentence, and we can use that for downstream services. We have the whole pipeline deployed in a distributed system to handle these large influx of articles that we get. And of course, the transformer-based model is where most of our computational costs go. Our downstream services is consist of different parts, and the service both consumes raw text and the contextual embeddings from our transformer. And at this step, we extract things like entities, product names, countries, and other types of organizations that we want to track. And we do that through a named entity recognition extractor. And we also consume our contextual embedding to predict whether a sentence is negative, neutral, or positive in a sustainability context. We are also currently working on extracting sustainability themes as well, so we know exactly what is being said. This could be if a sentence is related to green energy, deforestation, human rights, etc. So this classification model that we have here is basically a classification head on a transformer model that we have separated in terms of logic. And that means that we can have multiple classifications head consuming the transformer-based model. The reason why we have split it up as well is that the transformer model is the most expensive part, and by having it separated, we can quickly develop a new model that can consume the same text embeddings without having to reprocess a lot of our data, because we have data going back many years, and so it would be expensive to reprocess all the data. Next, we have our aggregation logic. We have a couple of billion sentences in our system, and we needed a way to convey all this data to our clients in a meaningful way that is not super complicated. So therefore, we aggregate all the data related to an entity, so it could be a company, with a frequency of 1 day. So that means you get a data slice for each day for a company. So for 1 year, a entity could have 360 different aggregation slices. And we do that for as well as the data makes most sense when it's aggregated up and compared on a daily basis rather than each of the samples underneath it. All this is then stored in a database, and we are then ready to serve it on the API. Our API is called SGD Signals because it is basically a proxy for the sustainability of surrounding a company. And we serve the aggregates to a client by them making a API request with a entity name or an ISIN code or the like, and we then fetch the underlying aggregate for that company, and that could be aggregate for 1 day if they're only interested in that, or all the data pertaining a particular entity, and that can then be used for, of course, visualizations, seeing a trend for a company over time. It could be used to identify specific periods where a company have had a lot of negative sentiment, and you can then probe into that and gauging why do they have that much negative sentiment on a particular, let's say, month, and you can then try and see what kind of risk does an investment in this company have. One of the reasons why we created this as well is that a lot of data surrounding a company, such as CO2 emissions or water, is usually updated yearly by company reports. Other data, such as human rights violations or deforestation, is also updated yearly or bi-yearly by non-profits or NGOs or the academia. And that means that there is a high latency on that kind of data. A lot of clients want to react more quickly because usually you see something in the media way before you see it reflected in the data. And this is what this NLP system can do, is spot this with a maximum of 1 day latency, and we can then convey that information onto our clients, so they can react much quicker to a company doing something negative towards the climate or any social rights or the like. And that is my presentation on how we create an outside in view on company sustainability performance. Thank you.